Hello everyone, hi guys, welcome to C++ Code Lab. Yeah, this course is going to take you from the scratch to the advanced level, how to become a C++ developer from the scratch to the advanced level. So we're going to take you from the low parts of, or from the grassroots of technology to the advanced level, so you guys will understand what we are, what's tech, what's code, what everything is all about. So the first thing we're going to take is hardware architecture. That will be our first topic, but we're going to be using the PowerPoint application to take you through that. Before we go into coding, you have to understand, and I have to bring this to a lesson first. That's the hardware architectures, that's the tools. Example, as a worker, or as a worker of any organization, or a worker of maybe a workmanship, you have to understand the tools you are using, so you can have a very advanced knowledge of how to use it. So that is just an example of what I'm trying to do here. So, and that is a very good way to start the lecture. So start from the hardware architecture level. So I'm gonna be taking the hardware architecture, sorry, pronounced that wrong, as the first lectures, and you're gonna understand that as I take you through it. So thank you. So the first thing I want you guys to understand is computers, which is, what is computer? Of course, most of us should know what computer is, and in fact, you might have been watching this video to a computer, or neighbors might have it, or family or friends, or or even when we are in very civilized world. So somehow most of us should have contact with that, but that's not what I'm going to. So now, what is computer? Like I said before, but I just wanted to get to understand that the first question should be, what is computer? So if I should ask you what is computer, what will you say? Okay, fine. Are you thinking? Okay, good. So let's just don't take our times that. So computer actually is what takes inputs, processed, and gives the output. So I'm going to draw it on the screen here so you guys can understand what I'm talking about. But first thing, I'm going to type that inputs, process, in output. So I'm going to duplicate this into 3 parts, so I'm going to use them. Okay, good. Come in. Don't worry about the PowerPoint, I'm not taking you that. I just use this to explain that's what is computer. Come in, sorry. Sorry, I love to make things look neat. I love it. And I'm very sure you love that too. So now I'm gonna draw a box representing our device. So I'm gonna use black color to draw that. I'm not taking your PowerPoint. I'm just sorry, don't worry about that. Just try and understand this explanation. So this should be white so we can see exactly what is there, but not the process I'm trying to put there, is device. So good. So now I want you to understand these three diagram, these three text 1, 2, 3. I want you to understand these 3 things. The 3 things that happens to every device, computers. So let me try and explain this to you. So like I said, computer is what takes inputs, then process the inputs, then what give out the outputs. It is a device that takes inputs, process, and give us outputs. As a computer illiterate, or probably you might not be a computer literate or literate anyone, literate, not literate, media. You have to understand that computer is actually what takes inputs, processed, and give out the outputs. So these three things you have to be familiarized with it, or you have to know it. Of course, you should. Something very simple, you should. So now, inputs. Computer is a device that takes inputs, process, and give out the output. So examples of what a computer. Let's just say this. Your laptop is not just a computer only. Your desktop or the laptop, your desktop, of course. So a phone is a very is a computer. A phone is your computer. A phone you have in your hand. You might be watching this thing through the phones. A phone you have is also a computer. Yeah, good. I love this diagram. So a phone is a computer. Sorry, I'm gonna change this color. So a phone is a computer. A phone takes same inputs, no, but not exactly like the computer does. Computers might be a little different from your phone, but they are of the same families, of the same family. They are all the same family. So a phone is what takes is also a computer which takes inputs, processed, and gives out the outputs. So it's also a device that takes inputs, process, and gives out the outputs. So maybe you how should I put this? You chat with your friends from your phone. You actually text you text or type on the keyboard on your phone, and it's sent. Sending the data to your phone to your friend is the output. That is exactly what you want. That is the output of the result of what you did. So the processing part is probably what you don't know. That is how they push out the computer, read your data and send it to your friend. So that is exactly what probably you don't know. So though we're gonna go there, but not now. So now we also have tablets. Tablets is also a very good example. It's also a family of the computer. The tablet you might also be watching this through regular tablets. I can't say. So a tablet is also a computer. It takes inputs, process, and these are the outputs. So whatever thing you might be doing on your phone, it takes inputs, process, and give out the outputs. You're listening to music, you go to your music store or playlist, and you click on the play. That is the input, and somehow the tablet, read your data, calculate or solve the algorithm how what you clicked, and somehow the computer played the music for you. That is the signs of somehow the tablet played the music. That is a sign of outputs. So the processing part might be something that is difficult for you to understand, because the computer is only the one I understand, but we'll be taking that later. So computer understand that's processing part. We won't understand the processing part, but just understand that computer is what takes inputs, process, and give out the outputs. So we also have router, the internet router. So internet router also is a very good example of computer. Is a very good example of the computer. Very good example of computer. Sorry for driving this, not fine. So the router is also a computer. It takes inputs, process, and give out the outputs. You connect your routers to your phone, laptop, or whatever it might be. That is just giving you the output, but there are some process some things you might have done to give you the outputs. I don't know, plugs that to the circuit, that might be just normal stuff. Click or set the time or connect it to your system. Like, maybe just get a new router, so you're going to connect it by having the password connected, stuff like that. Those are the inputting parts, and router sending you the details. sending data is the output. So just want to understand that it takes inputs, processed, and give out outputs. And also there is refrigerator. Sorry, did I pronounce that way? But refrigerator, 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 refrigerator. Can I even spell that? Oh my god, I'm not good. This is error. Error, I know it's error. Oh my god. Refrigerator. RF. Oh my goodness, I cannot spell that. Of course. Ah, come on. Oh my goodness, I can't spell that. Okay, good. So you're not in spelling. We're not in spelling bee class. Actually, we have get this spelling refrigerator. So now let's go forward. So refrigerator. I like that. So refrigerator is a good example of a computer. It takes inputs, processed, and give out the output. So example, you time your refrigerator to freeze your stuff for about 30 minutes, and the timing you input there is a sign of imputations, which is the input forms, and it's processed, like processed it and make it code for about 30 minutes, and the code is the result, which is the 30 minutes, which is the output. Code is the result, and which is the output. So it's a very good example of your TV. Yeah, your TV. Also, your TV is a good example of a computer. So your TV is an example. So your TV takes inputs, process it, and give out the output. When you go to a channel, you take your remote and pick a particular channel, and your TV channeled to the particular channel, and it shows exactly what is it. You input what is in your remote, and maybe you want to go to channel 1, and you go to channel 1, and it channels there. So the processing part might be very complicated for you to understand. You might not know how the TV channels to channel 5 or channel 2, and it shows the channel for you by giving you the output result, by doing exactly what you want, by performing your desire. That is the output of the TV, of the computer. So it's also a form of computer. Also, we have there are a lot of stuff. Microwave also is a good example. Microwave also is a good example. So microwave is also a computer. It takes inputs, process, and give out outputs. Of course, most of us have microwaves in their house. Or don't you? Don't you? Of course I don't. Of course I don't. That's not the same. But that's not bad. I don't have microwave. We have another way of preserving food. So now, microwave is also a good example of in computer. It takes inputs and process and give out outputs. Your input could be like also just like the refrigerator, that you time it. Maybe you want to preserve your food for about 5 minutes, or you want to make cake or stuff like that. So you can just time it, and it's processed it for you. And when the time is complete, the microwave stops, or give the signs to make sure that, of course, the stuff you preserve is done. So that is a process, or that is a process of a computer. It takes inputs, process it, and gives the output. By giving you can give it raw flour and process, and give you out the cake, stuff like that, or bread, or whatever you put there. So that is a forms of computer. So I hope you understand this. Like, a computer is what takes input. I just want you to understand that a computer is what takes input, process, and give out output. So it can be anything, any device that I mentioned, because they are all family of computer. They are all family of computer, both phones, tablets, routers, TV, refrigerator, microwave, even your fan. So there are a lot of stuff I cannot mention there, but just understand that things that takes input, process, and output, a computer is called a computer. So they are of the same family, because they are actually defined in the same way, but could have different functions. So the function of microwave is different from the function of refrigerator or routers or tablet or phone or TV, but they are all defined in the same way. So I want you to understand that. Okay, good. So now let's try and understand this processing part, which is the most important thing in this lecture. In this particular lecture, process, how the computers read the process, how does it process what we input. So I'm gonna bring example of a very good example. Let me try and give out one good example of how the computer processed our programs. Firstly, I'm gonna bring out example of a game. So example you so how let me try and bring it there. Sorry. How computer runs GTA game. So how computer run GTA game. So how your GTA game is being run in your computer. So it probably can be it can be any other thing, it can be any other program, but I want to use this as a very good example of what I'm trying to say. How your computer run GTA game, or it can be your any application, it can be even the application I'm using here, even your PowerPoint. So I just want to explain how the computer runs every programs by using a very good example of this. So I'm gonna take that from scratch. The first thing you're gonna do is to download the game. So I'm gonna bring that from scratch. So now I'm gonna get the game from Steam server. So I'm gonna draw what our Steam server looks like. So Steam is where you get games, where your games being stored. But you guys don't know that games, when you get your games. So let me put this in the front, or let me put it like this. Okay, so this is your Steam here. In your Steam there are different kinds of game. Your Steam is where you get your game, you understand. Of course you're a gamer, I know you're a gamer. So you can have GTA. Of course, too dark, I know you can't see it. I'm trying to fix it. I'm trying to fix that. Okay, GTA game. So this is GTA. In your Steam server there's GTA. There are a lot of games there, not only GTA. It can be, there can also be Cyberpunk. You have played Cyberpunk before. Cyberpunk. It can be, oh, I'm not correct. I'm correct. It's just because I added capital letter P. So there can also be a lot of game can be found there. There can also be, oh, just give me another game. Give me one. Okay, don't worry. Let me put Little Nightmare. Have you played that game before? Very, very scary. Little Nightmare 2. Sorry, she used this. Yeah. Okay, now, but let me don't go too far. So let's just use this 3. So now this is your Steam server. This is where your game you install your internet. The Steam server is online. Is online. This is online. Sorry. Sounds bad. Okay. Fine. Sorry for taking too much design. So now, I'm sorry for saying so. I'm used to that. Sorry. Good. Okay, now you download your game, and I want to take this from the scratch, though I want to explain how the game works. Like I said, we want to understand how the computer process our programs, because it takes input, process and give out output, but you want to understand how it processed it. So that is what we are trying to understand here. So don't drive us wrong, or don't be confused. I mean, so now you get a game about, that's GTA. GTA is about 100 gig. It's about 100 gigabytes. So if you don't know what gig is the size of a program, it can be your size of a data. The size of the data, there is bytes, and kilobytes, there's megabytes or stuff like that. So it's in gig. So you should know that you should be familiarized with what this size means, which is data. So you download a game from the Steam server with your router or your mobile internet, but let's use a router as an example. This is router, and we can also put all your mobile internet. Oh, sorry, I think I'm correct. Calls and correct. No, I'm not correct. My goodness, I can't spell again. Mobile. Don't you know mobile? Okay, good. I like this. So now you get GTA game from the live stream server. I want to copy this one here. I change the text to black. So you get a game. So now you're trying to download the game from this live stream server to your computer. So you get game from this thing and you download it into your computer. So it went straight to your HHD or SSD. If you don't know what HHD and HHD or SSD is a storage device in your computer. HDD. I'm saying HHD. Sorry. HDD or SSD. It can be either HDD. Sorry again. Oh my god. Oh god. So you connect your router. I'm gonna bring this. I'm sorry. I'm gonna bring it for you to understand. You connect your routers to your computer. So let me just do your computer here. This is just the hardware part. This is your computer, which is a CPU. And this is the major computer. So this is very good. So now here is the CPU. So here is the CPU. CPU is here, standing over here. The brain of the computer, the major part of the computer. So now you download the game from the Steam server into your computer, about 100 gigabytes to your computer, and install directly into your HDD or SSD. Like I said before, HDD is your storage device, is your hardware where your data has been stored, where every data in your computer has been stored. Like you download the game, video store, files, everything is stored in your HDD or SSD. You see that you have HDD or SSD. So HDD, I think, is hard disk drive, and SSD is solid. What's that self? Oh god, come in. Oh god, I have to straight the video. Solid state drive. So that is the SSD. Solid state drive. So that is SSD. So it can be your hard disk. So it can be your hard drive or SSD. So it's storage device. It's where your data has been stored. just understand that this is where when you get any data is stored in your HDD SSD. So it's a memory in your computer, storage memory, stores data. That is where your game goes through direct, and your CPU is the brain that does the work, that permits the HDD to takes this game. But I'll explain that. Now you connect your routers to your computer, and we went to GT. We went to live stream. You went to Steam server and you download GT about 100 gigabytes. And the amount of time it's going to get to your hard drive is not predictable. It can take long before it gets there, and it can be very fast. Example, sometimes when you download some things, remember when you get something, you just see your this method, all this stuff, this loading stuff. I'm coming. Let me just try and draw it for you, so you understand. Maybe this is the loading stuff. It's white. Let's use white, and let me use black for this, and let me use black for this. So maybe yes, so maybe this is your data, so let me put it here. It's usually here or anyway. So sometimes is here 2 hours, remaining 2 days. Sometimes you see those stuff when you, I don't know, it's somehow it looks like this somehow. Sometimes you see your internet when you download your stuff, so you just see this thing like it's remaining 2 days to complete the stuff. Sometimes remaining 2 hours, sometimes not even up to the time that it gets to get to your computer, your phone, stuff like that. So sometimes when you download stuff, the stuff just loading. Sometimes when it gets here or when it just started, it can just like remaining 2 days. Sometimes I'm scared. Why 2 days? Oh my god, I can't wait 2 days. But it's just those depends on the internet connection, your internet and speed. So now, good for this example. So now, the amount of time this MDT is going to get to your computer is not predictable. Like I said, sometimes it's just the depend on how fast your internet could be. If your internet is slow, it can take exactly that 2 days. It can take exactly that 2 days. Sometimes it takes 2 hours, sometimes 5 hours, and it depends on how fast your internet. And if your internet is then slow, it's going to take you a very long while to download the stuff. It's going to take a very long period of time to download a very simple stuff that doesn't take you a lot of time. So it depends on how fast your internet connection is. So that is not predictable to get into your system. So it is depends on your internet connection. So now after it gets to your HDD, that is your HDD. So now good. So we are getting to the game. We are getting to the main stuff. So like I said, once you understand how computer runs GTA game, so of course that is exactly what you need to understand. Of course you get the game in your computer and you are saying it, then you want to play it. You want to play the game itself. So then when you click on the game, like I said, it's computer is what takes input, process, and gives us the output. Now I want to understand the processing. So now you click on the game, double click on the game, or somehow you click on the game, either your phone or your computer. So you click on the game. So we want to understand how the computers, make these things work. First thing you have to understand is that once you click on your game, CPU, like I said, CPU is the brain of the computer. Is the one that does everything to make every programs in your computer works. So CPU is actually central processing unit. So it's the central processing unit of all units in your computer. It's the brain, major part of the computer that gives access to everything, like its main brain. So now you play it, or like I said, you click on the GT games, and what happens is, so you notice that this game you played, this game you have in your system, when you click on it, it's run fast. pop up to the screen. And how does it do that? Fine, this thing you are seeing here, Mr. HDD or Mr. or Mrs. SSD, it is a very slow component. It is slow, like damn slow. So what the CPU is going to do is that it's going to send little of the memory we have on this HDD here, which is the 100 gigabyte here, 100 gigabyte what we have here. It's going to send little of the memory to you. Sorry, I want to use this stuff. Good, I can see. No, I want to use you. I mean you. No, not you. I mean you. Yeah, you. So I want to use this stuff. So now let me try and create a connection here. Good connection. They are all connected to each other by all means. They are of the same family, the same blood, the same father and mother. Of course. So now I want to use this as RAM. So good, I like this, it's going cool. So now once you click on the game, the CPU is going to send little amount of memory. Once you click on the game, CPU is going to sense that yes, someone has clicked something, and it's going to send little amount of this size of the memory of this 100 gigabyte and send it to the RAM. So RAM is actually random access memory. Random access memory. We can also call it memory. Some people call it just memory. I can call it anyone. You can call it memory. Memory. So it's either you call it memory or random access memory. Any one of them, it's okay. It's still okay, but it won't get angry. Memory won't get angry. It's okay. It's fine. It's very peaceful going. Yeah, it doesn't get angry. Won't get angry. So now you can call it sorry. So yeah, you can call it random access memory or call it memory. So now the reason why CPU is sending that little amount of data, you can send at least, let's say the CPU send 5 or 7 gigabytes inside the random access memory. So now the reason why CPU is sending this data to random the memory is because HDD or SSD is slow and RAM is 100 times faster than HDD. But you expect your game to run very fast. And of course, you expect your game to come from screen. If the CPU should depend on the HDD, I'm very sure you'll be very angry. In fact, you can, of course, you'll be annoyed. You won't make things, just want things very fast. But CPU is trying to solve the situation for you, so it's going to send little amounts of this memory inside the RAM, and RAM is 100 times faster than HDD, like 100 times fast, 100 times faster and HDD. So it's gonna send this amount to this random access memory, and it runs so fast that it makes the job so quick for you to be able to see it on the screen. So memory can be, so now let's talk about the size. It can be 4. It can be 4 because we have, let's say, the amount of memory we have though we have 2, but people don't use 2 again. 2 doesn't really come on because there are some badass application out there. Once they see 2 RAM, they're gonna get crashed, like oh my god. Of course people don't use 2, but there is 2. But let me start from 2 at just an example of 2. So there is about 8, there is 16, there is 32, and there is 128. So 128 is the highest. I mean, still the highest. You can check it yourself, so you can check it. But 128 is the fastest, like the highest. I mean not the fastest. It's still the fastest, but you know, the highest. But that's where I'm going to, the highest size. So this memory could be, let's just 4, 8, 16, 32, or 128. So those are the size of memory. So we will talk about that. We'll talk about more about this later. But let me just try and say it. It's sending the half of the data, like little of these data, to random access memory to run the program for us on the screen. We're able to run the programs internally. But you're not seeing all those things. You just click on it. The processing part is not your concerns, it is a computer concern, the CPU concerns. But you just want the output, so that's exactly what it's doing for you. Then the next thing is the CPU also communicates with another family again, which is called TPU. So I don't mean to take this away. It's called the GPU. It's called the GPU. Sorry, and I think this thing should go down a little bit. It's kind of up too much. Okay, fine, good. So now you have, let me try and do this thing a little bit smaller. Yep, smaller. So now we have GPU. We also have another thing again. We also have VRAM. We also have VRAM. So now I think we are getting into the deep part of it. So now let me try and bring it from the scratch. Of course, you connect your router to your systems, your computers, or your mobile data to connect it to maybe to Wi-Fi. You can connect your mobile data to your Wi-Fi, or you can get your routers, or you can use your Wi-Fi too. Good, but router, let's use a good example of router or your internet, and you connect it to your computer and you download or you get installed Steam from this, and you install GTA from the Steam where your game is being stored, Cyberpunk, this Nightmare, but you actually get GTA because you want to play it. And when you download that, the speed of the Cyberpunk, GTA to your system, to your computer, is not predictable. Depends on your internet speed. If the internet is fast, it's going to get there fast. It's going to get, if it's slow, it's going to get there slow. So it's not predictable. So let's say it is the slowest, among the components of this part. It is the slowest among the components because it's not predictable, and it could be slow. And in fact, it's slow. Not it could be slow. It is the slowest part. So now it takes 100 gigs. So let's say it takes about 2 to 3 hours. Of course, it might not take up to that if you have a very fast internet. Of course, it might take more than that if you have a very slow internet. Of course, so now it gets to your computer and it is stored inside HDD, your storage device. And once you click on the game, which is what we want to do, your CPU sense that, like your brain, like just use human physicality to see that. If you get a pinch on your skin, you feel pain, and it is your brain that is doing actual work. I said, oh, you have been pinched, you have been hit, you have been slapped, you have been smashed. So it is the brain that is doing the major job. Without your brain, if you get, like, your arms is off your shoulder, you won't know because your brain is off. You don't know what is going on in you. So CPU is the major one that is doing the work. So the GPU sense that someone clicked or something is being clicked, which is the game, and what the CPU is going to do, that it's going to look at HDD and it's going to say, HDD is very slow, so to make this thing looks fast, so it's going to send little amount of data. Out of 100 gigabytes, it's going to send it little 7 gigabytes to memory, which is random access memory. So random access memory is going to make it faster because it is fast. It's going to make it run fast, and doesn't go there only. The CPU also communicates with your GPU and your VRAM. What is the work of these two things? First, this one is called graphics processing units. G for graphics, P for processing, and U for unit. So it's called the graphics processing unit. which is the one that render the graphics for you on the screen. So fine, you also have what we call VRAM. It's called virtual random access memory. Virtual random access memory. It stores the virtual memory, just like the way random stores the memory to run faster. No, stores temporary. So, and those memory, remember, those memories, they are temporary. They are not permanently stored there. Once you close the screen, they are all gone. Once you click on pen, one click on oh sorry, once you click on close, they are all gone. But I'll explain that later on. So now, so your CPU is going to communicate with your GPU in your virtual memory also, and now you know it's a game. So the game will have some graphics parts. Example, the character be the characters, and the graphics parts, those will be the waters, the roads, the map, the terrain, the trees, the wind. Every graphics in your game is going to be sent into this what we call virtual random access memory. They are going to store it in this memory. So it's just computer CPU that are going to store those things in memory. And what this one is doing, that is going to render those graphics out for you to see. It's going to render those graphics outside for you guys to see. So it is the GPU that is rendering those graphics for you. So just like the one I have here, this one I have here. So it is the graphics processing unit that give it for me, so I can actually work with it. So it is their memory. This memory is being stored here. Everything every materials I use are stored in this virtual random access memory here. So the same as the game, they are stored in this place. Your characters, the guns, the cars, every single stuff. The graphics is being stored here, and GPU is the one that render those graphics to the screen, that make it shows for us, render it to the screen for us. So do you get? I hope you get what I'm trying to say. So okay, good. And what if, let's go for that, what if the memory is filled up? You know, I said we can have at least maybe 8, 16, 32 and 130, 128. So now what if CPU send 7 gigabytes and you're using it's 8 gig, you know, somehow, let's say, let's just use 9 as a very good. So maybe CPU takes 9 gigabytes, sorry, 9 out of the space, out of HDD, and send it to RAM, and RAM is about 8. What do you think is going to happen? Okay, now I'm going to explain what's going to happen. Once CPU send that and they say it's too much, one thing you're going to notice is that your application you could be writing not responding. You should have noticed that if you use your computer very well. Sometimes you open several applications, like maybe I open more than one application. Like I open this one, I open this one, I open this one, I open this, I open this, I open this, I open everything, and the CPU send everything to the RAM. It send this to the RAM. It send this to the RAM. It send this to the RAM. Notice that the RAM is going to get filled up, and when the RAM get filled up, you're going to see that some of the RAM or even the application you're writing not responding, means that it has been filled up. So to send those data back to the HDD, and it will depend, not everything though. It's going to send the one that is not able to capable, like unable to carry out. So it's going to send it back to the HDD, and which I said HDD is slow, so it's going to make it run slower. So I hope you're getting this. So now the major part of it is to understand that it's the device, the computer is the device that takes inputs and give out outputs. It takes inputs, gets inputs, and takes output. So this is the processing part. Takes inputs, process, and give out the outputs. High inputs, processing, and give out the outputs. So now I hope you understand this. We get the game from the Steam GTA, about 100 gigabytes. The time is not predictable. it depends on your internet connection. And once it gets to your HDD, which is the storage device, once you click on it to play the game, the CPU senses that and send a little amount of data to the RAM, random access memory. So the RAM is going to run the game and runs the programs 10 times, 100 times faster, so you can see it. This is very slow. It doesn't depend on this. So it sends it to the data and also communicate with the GPU, which is the graphics processing unit. So once it's communicated with the GPU, it's going to render those graphics for us on the screen, and those materials being used on the screen is being stored on the virtual random access memory. And these things are temporary, because once you close the game, every memory stored here or every data stored here is gone. Every data stored here is also gone, because they are for temporary, for you just to view it only. So they are actually stored here temporarily until you delete it from your system, from your computer. That is when you're not going to see it again. So I hope you understand this simple illustration. And moreover, let me try and go a little bit deeper for you to understand. As actually I am I based on game development, so I want to explain more about that for you guys to understand. So now let's go deeper on this GTA game. Of course we have to. Are you interested? Of course you're interested. That's why you're here. Sorry, might be boring. But I don't say yes because I'm gonna get very angry. Of course, it's gonna be a boring class, not too boring. Sorry. So now this is there are two characters here. This is the hero. This is the good guy. This is the bad guy. In every game, there's always a good guy and then there's a bad guy. Sure, bad guy, good guy. So now let's use this. So now in every game, there's always called stats. Sorry, there's always called stats in every game. So every stats has health. The health percentage, let's say it's about 98.1, sorry, degree in percentage. So of course, so now, so we're gonna have also after health, let's say speed. The speed is about 16 percentage. Gun damage, or let's say gun has its own stats. But let's just put it together. Gun damage. Let's say gun damage. I'll explain that. Gun damaged. So let me just create something very simple. So I won't go really more deep. So this is the main character and this is the enemy. So there's always the enemy and there's always the main character. So now this is the main character, and the enemy tools has stars to some stars. So let's say this is about no, of course no, 20%, 20.91, and the speed is about 4. It's about let's say 10, because the main character is always stars is always a little bit different from the enemy, of course more higher than the enemy. So gun damage should be at least, I didn't put that gun damage here. Gun damage should be at least 13%. So whenever the gun is being shot, whenever the main character shoot the gun to the enemy, it's gonna reduce at least 13% of the health. So now let's say gun damage of the enemy should be 2.1 percentage. This is just a minor enemy. So now, well, not up to that, but anyway, so just understand this stats could be health, speed, and the gun damage. So all these things here are actually in your game, which most time you see it yourself. So your health, you're going to see your health yourself, Because if your health is about 98%, you're gonna see maybe maybe you get shot. Your speed, you're gonna notice your speed and your gun damage, how strong your gun is. This is how strong the gun of the enemy is, the speed of the enemy, and the health of the enemy. So now I want to explain how the games works itself. How game works. So now this is the main character, this is the enemy. So what I want to bring is that every games they have these stats there. Every game character I mean have these stats there. So all these things you're seeing, they are stored in somewhere in the CPU called register. They are stored somewhere in the CPU called register. I'm sorry, I'm gonna bring that right now. I'm not doing this. It's not really straight. It's not straight. It's not straight at all. It's not straight. I guess this is straight. So I'm gonna give it white. Or let me make it a little bit bold and white. Good. So now let me give it a white color. So it's color called register. Register. I know I'm not correct, of course. It's not correct. So now register, and we'll call ALU. ALU. And we also have a catch. So now these three things are stored in your CPU, doing a very great job, very great job. Without them, things might be difficult for your games. So now you click on the game. So you're in the game already. You're already playing the games, and your character gets shot, or the main character gets shot by the enemy. So now let's do some little calculation. I'll do some calculation, some little very simple basic calculation. I don't need to use calculator, but I'll use it for you guys to understand clearly. So now every stats we have in our game, they are stored in our Reddit stats. Everything we have here are stored here. They are stored in our Reddit stats, recorded in our Reddit stats. So of course you are going and you get shot by the enemy. So like I said, the gun damage of the enemy is about 2.1. So 2.1 minus 98.1. So let's do some little calculation. So calculator, and 98.1 minus 2.1 get 98. So of course once you get shot, it's going to get 96. We're going to get 96. That will be our actual current result. So of course when the game gets shot, how do you know those things work? First thing, those, like I said, those things are stored in the register, and when the main character is being shot, register is going to communicate with the ALU. ALU is called arithmetic logic unit. The A stands for arithmetic, the L stands for logic, and the U stands for unit. So the arithmetic logic units actually do the logic and arithmetic in your programs. So the calculation is to do this calculation. So the register is going to send but this is how it works. The RAMs, it comes from the RAM first. Once it gets the game shot, so the RAM is going to send that data to the register that, of course, the main character is being shot. So the RAM is going to communicate with the register that this result, this stats you have here, is not correct. It's not actually correct. So the register is going to send the data to the ALU to do the arithmetic, and the ALU is going to do the logic and calculate the gun damage of the enemy minus the main character health. So it's going to give us 96 as the current alt position. So let's copy it, current 96. So it's going to give us 96. Now our enemy, our main character is not used because it has been shot by the enemy. So if the main character do the same thing to the health, so its gun damage is about 13 only. So minus 20.1. So let's say 20.1 minus 13. The enemy is gone. Of course, 7.1 7.1. You know that any other hit like this is gone. Any other hit on the enemy is gone. So they are stored in the register, read by the memory. They are being read by the memory. So they are stored in the register. Whenever the game gets hit, so RAM is going to read that, sense that, and send out to the register that this actual start to the affairs number correct, and it's going to send the update one to the it's going to make the register get aware of the updated one, and the updated one is going to be sent to the arithmetic logic unit, and arithmetic logic unit is going to get the logic out by doing the arithmetic part, doing some calculation, and send data back to the register. And that is how you guys see it on the screen. And these things here, this stuff you see is even more faster than the RAM. It's like damn fast. It's damn faster than the RAM itself. So this one you see here is more faster even than the RAM, and it's gonna do those things very fast. You notice that when you play the game, the health is gonna reduce so far that you guys, you won't even notice that something happens. You notice that something has been reduced. If you notice that it's gonna run like in microseconds, that it's gonna like very damn fast. So that is how those things work. So it's gonna work in microseconds, and it's gonna make those it's gonna put the results there really fast. Like, but also communicate with the GPU, also the graphics processing unit that is going to feed for you, and data is going to be stored in the VRAM. So all these things here, they are connected in one component and they are all connected to the CPU. And sorry, I won't be talking about this now, but I'm going to begin up here, so we'll be talking about this later, which is the cache. So let me try and draw the speed, or how fast your data is going to be run. Let me start from this one here. So now the first thing is your routers. Of course, no, see your routers. Let me use SSD because that's the major part, SSD or HDD. And I'm gonna use what again? After that, I'm gonna use your RAM. Of course, it's a RAM. Am I sure it's a RAM? So let's use routers firstly. So, though router, yeah, let's use router. That's okay. So, HDD, RAM, and we have register. And we have cache, and it is recorded that this is the fastest of it all. The fastest of everything's more faster. So from the routers we have here, we don't know the time is going to spend to get the game GTA from the stream to our HDD. It takes years. Sorry, does it take years? Oh, okay. It takes days if it is slow, and if it gets to HDD, when you click on it to run the game, it's going to take a lot of time. But for it not to take time, your CPU is going to send the amount of data, little amount of data from the game to the RAM. So RAM is 100 times faster than HDD, and the RAM sends the data to the register. And sorry, also I'm sorry for saying that After RAM, we also have register, which where we stores our stars, game stars. So though even register is faster than RAM. We also have cache, and which is the fastest. So I think this is everything you guys should understand right now about the hardware architecture, and I hope you guys get me. And I hope this thing is not really difficult, because fine, like I said, computer is what takes inputs, process, and give out output. And here is the processing part of the your CPU of your computer, of running every game. And every game, oh, it's not just GTA. It's about every programs you run on every programs you run on your computer. This is how they actually works. This is how it actually works. When you get them to your HDD, you click on it to run it. The CPU is going to sense it like SANSE. It's going to sense it and send little amount of the details to your RAM, and when RAM receive it, it's going to run it very fast, so it can deliver it to the CPU, or yeah, it can give the CPU to view result. And after that, your CPU communicate with your graphics processing unit, and the data are stored in your VRAM for the GPU to be run. So they are all connected in one component, and this is how your games work. I hope you understand this stuff. Though we are not talking about game development, but at least you have to understand, or of course, not even at least, you have to understand the hardware architecture. And as C++ developers, because C++ is actually of a low-level development. So we'll be talking about that later on. What is low level or high level? So in our next class, we're going to be talking about introduction to programming language. So that will be our next topic, introduction to programming language. So thank you everyone. Bye. Have a nice day.